Hello students, welcome back to Akshar ID Foundation classes. I am your chemistry faculty, S. Mohan. So grade 9, we started the volume 2 in that the first chapter, organic chemistry, general organic chemistry, right? In this general organic chemistry, we completed synopsis 1 and we are in synopsis 2, right? And in the last class, we were discussing about the classification of organic compounds. Okay, we were discussing about what? Classification of organic compounds like open chain, closed chain. Again, open chain, we discussed about the saturated, unsaturated, alkanes, alkenes and alkynes, right? And we discussed how to name them. What are the general formula, right? This all we discussed. So we completed open chain part from this second synopsis. Now we should go to today's our topic is about the closed chain. Okay. So before going to the closed chain, just in once briefly we revise the first one. So see students, here this is a classification of organic compounds. Now in this classification of organic compounds are open chain or closed chain. Open chain, saturated, unsaturated. Saturated are generally alkenes, which consist of all single bonds, and unsaturated, which consist of double bond and triple bond, right? So double bonds are called alkenes, which consist triple bond are called alkynes, right? This part we have completed in the last class. Now today we are going to discuss about this part. That is what closed chain. Closed chain, again they are classified into two types called homocyclic, heterocyclic. Homocyclic, again alicyclic and aromatic. Now today's our topic is this, but before going to this one, once again just briefly we go through this one, right? So now open chain means what? Like this. So you can see here, this is the open chain. Okay, so this is a open chain, straight chain, okay, and it is called N-pentane, and this is butene, okay, and isobutane. Like this is all called open chain. This already we discussed in the last class, right? And again there are hydrocarbons. What are hydrocarbons? The binary compounds which contains only carbon and hydrogen, okay, only carbon and hydrogen. The compounds are called hydrocarbons. Hydrocarbons are classified into C, saturated and unsaturated. And saturated or alkenes, with the general formula CnH2n plus 2. Example, methane, ethane, propane, and I said due to practice up to 10 compounds. No, so once you check, so these are the 10 compounds of alkenes: methane, ethane, propane, butane, pentane, hexane, heptane, octane, aniline, and decane. This I said due to practice, right? So I hope that you have practiced. But once again, you see here, okay, these are the 10. Then come to the unsaturated. Unsaturated alkenes are there, alkynes are there. Alkenes which contains at least one double bond, okay. Alkynes are at least one triple bond, right? So here again 10. This also is due to practice. The general formula is CnH2n. So these are the alkenes. Ethene, propene, butene, pentene, all ene will come, okay. Now then come to the alkynes, last ine, so which contains at least one triple bond, and these are the 10. I said due to practice, so hope you have practiced. So they are ethyne, propyne, butane, pentine, okay, hexyne, heptine, octine, and all this, right? So till there we are completed in the last class. Today's our topic is closed chain or cyclic compounds. What is closed chain? See, in the open chain, students, what we have discussed, for example, butane. So how we write the butane? Okay. So how you write the butane? But means what? 4 carbons. Ane means what? All single bonds, right? So 1, 2, 3, 4. These are the 4 carbons. Okay. And it is open chain. Okay. First carbon, second carbon, third carbon, fourth carbon, right? Now, and of course they are with hydrogen CH3, CH2, CH2, CH3. This is a butane. Okay, this is open chain. But in the closed chain, what happens? This first is attached to the fourth one, like 1, 2, 3, 4. Now see here, fourth one is attached to the third one. Okay, so now it's forming like a ring, closed. So this is called a closed chain, right? For example, 3 carbons are there, you think. So that's called what? Propane. Propane. Okay, CH3, CH2, CH3. So how many carbons? 3 carbons. 1, 2, 3. But here it is straight here. Okay, but the cyclo, what happens? The first carbon is combined with this third carbon. Like, here you can see. Okay, so first carbon, second carbon, third carbon. First carbon is combining with the second carbon, second carbon is combining with third carbon, third carbon again and combining with the first carbon. So it's what's happening here, it's forming a ring, okay, closed structure. Okay, this is closed, this is open. Okay, this is closed, this is open. So here how many carbons are there? Then how can you give the name for this one? How many carbons are there? 3 carbons. 3 carbons is what? Prop. And what type of bonds are there? Single bonds only there. So propane. But actual propane formula is what, according to alkanes, what's of general formula? CnH2n plus 2. So CnH2n plus 2 is a propane, right? So here how many carbons? 3 carbons, C3. Then how many hydrogens should be there? 2 3s are 6 plus 2, 8. 8 hydrogens should be there. But here how many hydrogens are there? Here 2 hydrogens, here 2 hydrogens, here 2 hydrogens, because carbon valence is 4. So here only 6 carbons are there, right? So here this is propane, but here only 6 carbons are there, and it is closed. Okay, so as it is closed, we just add cyclo. What we add? Cyclo. So name of this one is a cyclopropane. So here the triangle. Here triangle means what? It's not just triangle. So it's like in mathematics, how you draw the triangle. It's not like that. Here the meaning is what? Here 1 carbon is there, here 1 carbon, here 1 carbon. So it's made up of 3 carbons. And this line is there, so this represents single bond, single bond, single bond. So 3 bonds are there. So this is propane. Okay, 3 carbons, prop, all single bonds, propane. But here it is closed, so that's what we are adding, the cyclo. So the name of this one is cyclopropane. Is this clear? Now see here the square means what? It's not like just square of mathematics. Okay, so here the square of carbons here. Okay, so here at this corner 1 carbon, other carbon, third carbon, fourth carbon. So here 4 carbons are there, right? So 4 carbons means what? 4 means what? Bute. 4 is what? Bute. And all single bonds are there, so butane. But here it is closed here, so we should add cyclo as a prefix. So this is called the cyclobutane. So this is an example for the closed chain in that homocyclic. Okay, first we see the closed chain. So closed chain is what? Compounds containing at least 1 ring. This is very important. Ring means what? A closed structure. It may be like triangle shape, it may be square, it may be hexagon, it may be pentagon, anything. Okay. So it at least consists of 1 ring in this structure is called cyclic compounds. If the ring contains 1 type of atoms, the compound is called homocyclic. So these all are homocyclic. What is given for homocyclic? If the ring contains 1 type of atoms, so C, only carbon is there. C, only carbon is there, no other elements are there. Only 1 type of atoms, if they contain, they are called homocyclic. So these are example for homocyclic. Clear? And if the ring contains at least 1 heteroatom, hetero means what? Different, other than. Actually, the hetero word is taken from the Greek or Latin. So there, the hetero meaning is what? Different. Hetero meaning is what? Different. So here homo means what? Same. So here all are carbons only are there. Okay, carbon, carbon, carbon. So carbon, carbon. But along with this carbon, if any other atom is there, okay, like maybe generally sulfur, oxygen or nitrogen, mostly repeated elements are combined in this one are sulfur, oxygen, nitrogen. So these are different atoms. Okay, so if these atoms are combined with these carbon atoms, then they are called hetero. Hetero means what? Different. Along with the carbon, any other element, okay, is included in that ring. Okay, then they are called hetero. I'll give you an example. Okay, so heterocyclic. Heterocyclic means what? At least one heteroatom. Hetero means what? A different atom. If same atoms are there, that's called homo. If different atoms are there, that's called a heteroatom or called heterocyclic. Okay. Now see, so two types, one is homocyclic and second is what? Heterocyclic. So here we discuss about the homocyclic. Homo means what I said, same. One type of atoms only should be present in the ring. Okay. So now here, this is also called carbocyclic compounds. Why carbocyclic? Because all atoms are carbons only. In this cycle, all atoms of carbon only. In this cycle, all atoms of carbon only. So this ring consists of all carbon atoms. This ring consists of all carbon atoms. For example, if I draw the structure like this. Okay. So how can I draw the structure? Okay, if I draw the structure like this, now, okay, so this is one structure. So here all carbon atoms only. Okay, so all this ring consists of 1, 2, 3, 4, 5. Okay, 5 carbons, right? So all are carbons. So that's what this all carbons means same atoms. So this is called homocyclic, and it consists of all carbon atoms only. So that's what you can also call as a carbocyclic. Carbocyclic means what? That ring should consist of all carbon atoms only. Okay, so when all atoms of the ring are carbons, the cyclic compounds are known as homocyclic compounds or carbocyclic compounds. Okay, so example, this is cyclopropane, which consists of 3 carbons in a ring, and cyclobutane, which consists of 4 carbons in a ring, and here this is what? A cyclopentane. How many? 1, 2, 3, 4, 5. So pentane. Okay, so these are called as a homocyclic or carbocyclic. Clear? Okay, so this is homocyclic means what? All carbon atoms only. Right. Now here are some examples. Okay, we discussed about this one also: benzene, naphthalene, and anthracene. Now, homocyclic compounds are further divided here. Homocyclic compounds are again further divided into 2 categories. One are called alicyclic. Okay, alicyclic homocyclic compounds, and second are called aromatic. Aroma. Remember here, aromatic compounds or benzenoid compounds. Okay, what are alicyclic homocyclic compounds? Nothing but aliphatic, like open chain we discussed. Like, so alicyclic means what? Which has the properties of it possesses the properties of like aliphatic hydrocarbons. Okay, aliphatic carbon compounds. Okay, so see here, homocyclic compounds. Homocyclic, just now we discussed. Homo means what? The same. Cyclic means what? A ring-like structure. Homocyclic compounds which resembles aliphatic. Remember here, which represents aliphatic. Alicyclic. Ali means what here? Aliphatic. Okay, means open chain structures. Okay, are called alicyclic compounds. So example you see here, this is cyclopropane and this is a cyclobutane, just now we discussed. Now come to the next one, aromatic. Aroma means aroma means what? Smell, like fragrance. Okay, the smell. Okay, a characteristic. You know that benzene, the first when the benzene was discovered at the time, the benzene has one characteristic smell. Okay, so then they are given the name of the compounds which consist of benzene rings or aromatic hydrocarbons. What they are called? Aromatic. So here aromatic compounds or benzenoid compounds. So here benzenoid means what? Because it consists of at least one benzene ring. Benzene formula is what? Do you know the benzene? Benzene is a C6H6. Okay, so benzene formula is what? C6H6. Actual structure, how would you believe the benzene structure? See here, 6 carbons. 1, 2, 3, 4, 5, 6. Okay, and then see here, first we draw the single bonds all. Okay, and the 6 hydrogens are there. 6 hydrogens. Okay, 6 hydrogens. But here you see here, you know that carbon valency is 4. Carbon valency is what? 4. Already we discussed. Carbon valency is 4. But here if you see here, carbon is forming only 3 bonds. 1, 2, 3. This carbon 1, 2, 3. This come 1, 2, 3. This come 1, 2, 3. So only 3 bonds are there. Okay, but carbon valency is 4. So to satisfy that, here there are a triple bonds will be there. Okay, sorry, double bonds are there. Alternate double bonds. Alternate double bonds means what? See a first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. So there is a double bond between 1 and 2, 3 and 4, 5 and 6. Alternate double bond. So this structure is called benzene. What is called a benzene? Very important. So benzene formula is a C6H6. This is a benzene if we draw like this. Okay. In short, how can you draw? In short, we can draw just simple hexagon. Hexa. Why? Because 6 carbons are there. So hexagon. Okay. With the alternated double bonds. With alternate double bonds. Or generally we can draw. Sorry, we can draw like this also. Like this also. So these all are the structures of okay, benzene. So remember that benzene formula is a C6H6 and benzene is a ring-like structure, hexagonal structure where it has 3 alternative double bonds. Okay, alternate double bonds. So here you can see this is a benzene. Can you see a benzene? So this is a benzene. 1, 2, 3, 4, 5, 6. Okay. So 6 carbons, okay, 6 carbons with alternative double bond. So this is called benzene, right? So here, so now you see benzene, compounds containing one or more fused isolated benzene rings. Okay, aromatic means what? Benzene. Remember that aromatic means what? Benzene. That's all. Okay. So here benzene means what? Which consists of a 6-member ring of carbon atoms. Okay. With the alternate single and double bond. So single bond, double bond, single bond, double bond, single bond, double bond. Like with the alternate single and double bonds are there, they are called benzene rings. Okay, benzene, that's called benzene. Like this benzene rings are attached. Okay, so you can see only one benzene ring is there, you can call it as a benzene. If 2 rings are there, see here, 1, 2 benzene rings are there. This is called naphthalene. What is called? Naphthalene. Similarly, 3 rings are there, anthracene. What is called? Anthracene. So these all are consist of what? Benzene rings. Okay. So benzene is a aromatic compound. Okay. So that's what. And they are in ring-like structures. So they are called aromatic compounds or benzenoid compounds. Clear to you? So this is about the aromatic compounds. Any doubts, friends? So once again, see here, allycyclic, homocyclic, and aromatic compounds. Right. Okay, so condition for aromacity, this is also very important. So compounds must be cyclic. What is the cyclic? Ring-like structure. That's the first thing. The compound must be planar. So, okay, in which the hybridization is sp2. Already we discussed in the first synopsis. Okay, and there should be a delocalized. See, this delocalized pi electron. This I will explain you in the next classes because this is an introduction. And this is called as Huckel's rule. Okay, what is that? Huckel's rule. And Huckel's rule ring is applicable only for the monocyclic systems, and aromatic compounds are examples for delocalized bonding. Okay, so in this, what mainly you have to remember is they are cyclic. I'll explain this Huckel's rule in the when we discuss about the benzene individually. Okay, there we can discuss about the Huckel rule. Okay, so next the compound should be planar and they undergo the sp2 hybridization and they should consist some aroma, means a characteristic fragrance, okay, or smell, right? So these are the conditions for the aromacity, right? So now in the last slide, okay, last slide we have seen that homocyclic we have seen. Homocyclic means what I said, all carbon atoms only, no other elements are present in that ring, right? So see here, carbon, 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 only same type of atoms, carbon, 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 no other. So carbon, 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 carbon. So here also carbon, 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 carbon. So all are same type of atoms, okay, are present. So these are called homocyclic. What they are called? Homocyclic. So this is a part of homocyclic. Now we see the heterocyclic. Heterocyclic means what I said, one different atom should be there. Along with the carbon, there should be one more atom in that ring. Okay, one more atom in that ring. Remember that. Okay, in that ring. So here, along with the carbon, there should be one more element. Generally, mostly elements which are present in that one, like sulfur, oxygen, nitrogen. So these are the mostly repeated elements in the heterocarbons. Okay. So hetero means what? Different. Hetero means what? Different. Cyclic means what? Ring. Okay. Compounds. So the compounds which contains the ring-like compounds which contains at least one hetero means a different atom. That means what? Other than carbon. Carbon also present. Other than carbon, one atom. Okay, is present. So see a cyclic compounds having at least one hetero atom. Hetero atom is what? Other than carbon. In a ring, they are called heterocyclic. Okay, compounds in a ring. In a ring along with the carbon, if any other than carbon, one more element is present, then that is called a hetero different cyclic ring-like structures compounds. Okay, so that's about the heterocyclic. In that heterocyclic, again you see a alicyclic, heterocyclic compounds are there and aromatic, same. Okay, alicyclic and aromatic. Alicyclic means what I said, ali means what? Aliphatic. Okay, so aliphatic means what? Like open chain. Okay, so here the heterocyclic compounds which resemble aliphatic in nature means what? Easily they are actually why they are called as aliphatic, because they are very weak. Means their bonds are very weak and they are unstable. Unstable means what? They are not perfect stable, they are less stable. So easily they can split. Okay, easily the break and bond. Okay, and they easily can be converted to aliphatic. Okay, so that's what here alicyclic heterocyclic compound means what? Heterocyclic compounds which resembles aliphatic nature in their properties are called alicyclic heterocyclic compounds. Alicyclic heterocyclic compounds. Clear now? Okay, so alicyclic heterocyclic. Hetero means what? Different atom. Remember that. Hetero means what? Other than. Now example you see here. Oxygen is there. Okay, what is it? Oxygen. In the oxygen, if you see here, students, here, this is a cyclic compound. Why? Because it is here, it is a closed ring. Okay, so it is a closed ring like this triangle shape. Right? Now in that ring, you see this ring here, carbon is there. Here also carbon is there. But here, if you see here, oxygen is there. What is here? Oxygen. So here, two carbons and one oxygen. So this is a ring actually. Okay, there is a ring. In the ring, one other element is present here. In the ring, other element is present. So then it is called alicyclic hetero. Hetero means what? Different. Okay. So here between the carbons, one other atom, oxygen, other than carbon, one oxygen is included or added in that ring. So then it is called alicyclic hetero. Clear? Now see here oxygen also. Okay, oxygen also, this is a closed ring, see a closed ring, and in this closed ring, see a carbon. So in this carbon is there, but here if you see, you can see the oxygen here. Along with the carbon, there is one other element is there. Oxygen, different element is there. Okay, so this is called oxygen or heterocyclic, hetero, different, cyclic, closed. Okay, other than carbon, some other element is also present there. So then it is called heterocyclic compounds. Clear? Heterocyclic compounds. Similarly, here you see the nitrogen is included. So 1, 2, 3, 4. See, no element is written here like symbols like nitrogen or something. Then the meaning is what? There are all are carbons. So here also no other symbols are there. Means what? These all are carbons. And here one oxygen is added. So these are all examples for heterocyclic. Heterocyclic. In that heterocyclic also they are alicyclic. Okay, because they have aliphatic in nature. Okay. In the second one is what? Aromatic heterocyclic will come now. Okay. Alicyclic we discuss now. Ali. Now let's come now next topic. Second one is what? Aromatic heterocyclic. Now let's see. Yeah, aromatic heterocyclic compounds. Okay. Aromatic heterocyclic, aroma means what I said, aroma, okay, which has a characteristic smell. Okay, so aromatic carbon compounds Okay, means what? Aromatic hetero. So again here hetero means what? Same, different. Cycling means what? Ring-like structure. And compounds. So heterocyclic compounds which resembles aromatic nature, okay, and in most of their properties they are called aromatic. Aroma means what? I said smell, one characteristic smell. So these are the aromatic, okay, compounds, but they are heterocyclic. Hetero means what? One different element will be there along with the carbons. So see now, so no symbol other elements is there. So the meaning is what? These all are the carbons. Okay, so these are carbons. In that one, nitrogen is included, hetero. But these characteristics resembles what? They resembles the aromatic nature. Okay, they resembles what? Aromatic nature. So again see here carbon, 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 carbon. Along with that, what is there? Oxygen is there, hetero. Different element is there, hetero. Okay, heterocyclic. Cyclic means what? Close, heterocyclic. But these properties resembles what? Aromatic. Okay, so that's what they are called, aromatic. Is this clear to you? So these all thiophene and pyridine, these all also examples for them. Okay, aromatic heterocyclic compounds. Did you understand? So students, this looks like a little confusion. Okay, but it's very easy. So now I'm going to see here, this is a table of alkanes. Already we discussed about alkanes in the last class. So alkanes, so the first member is methane, ethane, propane, butane, pentane, hexane, heptane. These all are the alkanes, right? And their formulas, you see, methane formula is a CH4, ethane is C2H6, propane is C3H8, butane is C4H10. So these are the formulas, right? Now we see only see the formulas. CH2, this is a methane formula. This is C2H6, this is an ethane formula. What is the difference between these two? Once you check. So here only one carbon is there, here two carbons are there. So the difference between these two is one carbon. Correct? One carbon, two carbons. And here you see four hydrogens are there, here six hydrogens are there. So difference is four hydrogens, two hydrogens. Difference is what? Two hydrogens. Right? So if I add this CH2 to here, to methane, CH2, if I add that, then I will get ethane. What I will get? Ethane. Now, if I add CH2 to ethane, okay, 2 plus 1, 3, 6 plus 2, 8, I will get propane. If I add CH2 to propane, I will get butane, C3 plus 1, 4, 8 plus 2, 10, like this. So, these all are differ to the next element with the CH2. So, such a compounds, the carbon compounds which differs with the CH2, to the next or previous element, previous compound, then such a group of compounds are called homologous series. So, a series of carbon compounds which differ with the CH2, okay, is called homologous series. So, these all are homologous series. So, hence they contain some similar type of properties, okay, the similar properties, okay, they'll have the similar properties. So, this is called homologous series. So, these are what? Alkanes. So, alkanes comes under homologous series because they differ with one compound to other element CH2. If you add CH2, again you will get again CH2. Right, these are the alkanes. Now, the question is that whether only alkanes comes under homologous series. What about the alkenes and alkynes? Okay, let us see now. So, alkenes also. So, this is alkene. Okay, alkene. So, alkenes here, that is what? Ethene, C2H4. And this is propane, C3H6. So, 2 carbons, 1 carbon. So, difference is how much? 1 carbon, right? And 4 hydrogens, 6 hydrogens. So, difference is what? 2 hydrogens. Means what? Again, if you add CH2, you will get this product. If you add CH2, you will get the next product. Again, you add CH2, you get next product. So, here this all alkenes also differ with CH2. They differ with what? CH2. Clear? So, hence, these, okay, are also homologous series. These are also comes under the homologous series because a series of compounds which differ with what? CH2. Okay. Now, these are the alkanes. What about the alkynes? Yes, alkynes also C2C3 means one carbon is different. H2H4 means two hydrogens is different. C3C4 one carbon is different. H4H6 two hydrogens is different. So now these are also differ with the CH2, hence these are also called as a homologous series. Now did you understand the homologous series? So homologous series is what? See now, alkanes have general formula CnH2n plus 2 and each member differs from the next member with the CH2. How they differ? With the CH2. Okay, so one member to other member the difference is only CH2. So this is also called methylene group. Even they are similar, okay. So even they have the similar chemical properties. So such group, such series of compounds are called a homologous series. Okay. Now compounds having the same functional group and similar properties that differ from the adjacent members by CH2 group, okay, constitute the homologous series, and the phenomena is called homology. Is this clear? So these are the homologous series. So the members of this is a homologous series, and here's one new word has come for you. What's that? Functional group. Okay, the new word is that's called functional group. The functional group will come in the next topics to you. Is this clear, students? So homologous series means what? Which differ with only one carbon and two hydrogens. Right? So that's about the homologous series. Okay, so these all are examples for the homologous series. Acha, now next come to the alkyl group. Alkyl. So alkyl group means what? Now once go to the alkane. So these are the alkanes. So these are what? Alkanes. Methane, ethane, propane, butane, pentane. Okay, this is alkane. So here alkane formula, for example, methane formula is what? CH4. CH4. Okay. Now from this CH4, if I remove one hydrogen, so then what is left here? One carbon. Out of 4 hydrogens, I removed one hydrogen. So what I'll get here? 3 hydrogens, right? Now similarly, we'll go take the ethane. Ethane is what? C2H6. Now from that, I'll remove one hydrogen. So now what is left now? C2. Out of 6, one hydrogen. So H5. Now I'll take the next member, that is C3H8. C3H8. From that, I remove one hydrogen. So what I'll get now? C3H7. Okay. So when one hydrogen is removed from the alkanes, then what the new series of elements, new group of compounds will form, that is called alkyl group. What is called? Alkyl group. So general formula is what? General formula you have to find out. See alkane. Alkane general formula is what? CnH2n plus 2. So see here, alkane, CnH2n plus 2. From that we are removing one hydrogen. So the new formula becomes what? CnH2n plus 1. So this is a formula of alkyne. Okay. So alkyl. So alkyl. So these are the alkyls. Okay. So one hydrogen, when you remove one hydrogen from the alkenes, then we can get the alkyl group. Okay. So now this hydrogen if removed, okay, but here now see, for example, in this form of structure, right? So CH4. So 1, 2, 3, 4 hydrogens are there, right? So this because carbon valency is 4. Now if I remove one hydrogen, so I'm removing one hydrogen. When I remove one hydrogen, then is it valency or satisfied? No, carbon valency is 4, but here 3 hydrogens only are there. One valence electron is free, right? So that electron means this fourth bond is incomplete. The fourth bond, to complete it, it can combine with any other elements or group of elements. Then a new type of group, of compounds are formed. That group is called functional group. This we'll discuss later. Don't be confused here. So till as of now, you remember that from alkenes, if you remove one hydrogen, we can get the alkyl group. Okay. If you remove one hydrogen, so see alkyl. This is an equivalent obtained. Radical obtained by the removal of hydrogen, one hydrogen atom from the molecule of paraffin. Okay. So there's alkenes. So yeah, alkane CnH2n minus plus 2. From that one hydrogen we are removing. So what we are getting new group, that is called the alkyl group. Clear? It's a very simple alkyl. Just from the alkanes, remove one hydrogen. Okay, so that's the alkyl group. Now if you remove one hydrogen, then that is called a primary alkyl group. What is called a primary alkyl group? So here, the group formed by the removal of a primary hydrogen means what? One hydrogen. That's called a primary alkyl group. Similarly, secondary means what? A group formed by the removal of secondary hydrogen atom. Okay, is called secondary. Similarly, tertiary. Tertiary means what? Ternary. Okay, tertiary hydrogen atom. That's called a tertiary alkyl group. Clear to you? So, with this, the synopsis 2 is done. Okay. Now we have a questions here. Now try to answer how far you understood. Let's check now. Which of the following is an example for homocyclic or carbocyclic? Homo means what? Same type of element should be present. Or carbocyclic means what? All carbon atoms only should be present. If only carbon atoms only present, then we don't write any other symbol there. If any other element is there, then we can write N, S, O, something like this we write. So now you see here, which of the following is an example for homocyclic? So can you see anything, any other element? No, the meaning is what? All carbon atoms, all carbon atoms, all carbon atoms. So no other elements are there. So that's what the answer is, all. Okay, all are homocyclic. Clear? All are what? Homocyclic. Now second one you see here, which of the following example for heterocyclic? Hetero means what I said, along with the carbon, if any other element is present in that ring, in the ring if any other element is present, then that's called as a hetero. Okay. Now say which of the following hetero? Hetero means what? Other atom. So here closing, no other element is there. Here, yeah, here you can see one nitrogen is there. Here, no other element. Here, no other element. Only we can see the nitrogen here. So the option is the second option. This is a heterocyclic compound. Very simple now. Now third one. Third one is what? Which of the following is an example for the aromatic? Aromatic compound is what? Benzene I said. What is the benzene formula? C6H6. With what is the structure? Hexagonal structure with the alternating double bond. Okay. Now you see here, where is the hexagon? This is not hexagon, this is not hexagon, this hexagon, this hexagon. But here you see alternate double bonds where are present here. Okay, here alternate double bond is not present. So answer is 3. Benzene. Benzene is a aromatic hydrocarbon. So the option is 3. Right? Are you following? Yes. Then come to the which of the following is an example for the aromatic and heterocyclic. Aromatic and heterocyclic. Right? So here aromatic, heterocyclic, this is alternate double bond with oxygen. Yes. Alternate double bond. Yes. Alternate double bond. Yes. So all them. The answer is fourth option. Clear? Now, which of the following is an example for saturated? Saturated is what? Alkanes. Answer is 1. Unsaturated hydrocarbons. Alkanes are saturated. Alkenes and alkynes are unsaturated. Alkane is saturated. Alkene, yes. Alkane, yes. So both are there. So the answer is both 2 and 3. This is the right answer. General formula of alkane, just now we discussed CnH2n plus 2. CnH2n plus 2. Alkene, CnH2n, just 2n. Alkyne, CnH2n minus 2. Okay. Alkyl, CnH2n plus 1. Because I said no, alkyl group is formed by removing one hydrogen from the alkane. So CnH2n plus 1. Right. So these are the next. Which of the following is aromatic? Okay. Aromatic. Benzene, yes. Anthracene, yes. Pyridine is yes. I think answer is all. Okay. The fifth one answer is what? All. All are the answer. Right. Now, which of the following is not a carbocyclic compound? Carbo means what? It's only carbon should be present. They are called carbocyclic. Correct? So, carbocyclic compound. Right? So, now what is the answer for this one? Yeah. So, which of the following is not a carbocyclic? Means what? Along with the carbon, some other things should be present. So, that is called as a, okay, carbocyclic. Come on, what's the answer now? Benzene, anthracene, oh no, sorry, this one, no? Cyclopentane, all pentane, naphthalene, thio means what? Sulfur. Thio means what? Sulfur. The answer is 3. Next, a group of closely related compounds which can be expressed by the general formula and which consecutive numbers differs by 14. That is homologous series. Why? Here I said 14 is there. Why the 14? Because I said you just now that in the homologous series, they differ with the CH2. They differ with what? CH2. Okay. And you know that what's the carbon atomic mass? Atomic mass of the carbon is 12. And what's the hydrogen atomic mass? Hydrogen atomic mass is 1. So 1 2s are 2. So 12% is what? 14. They are differing with CH2 means what? They are differing with 14 in their mass number. Okay. So they are called homologous series. Aromatic hydrocarbon. So aromatic hydrocarbon is what? Huckel rule. Huckel rule, just now I told you 4n plus 2. So the Huckel rule is, this is the right answer. Which of the following is a benzenoid? Benzenoid means what? Which consists of benzene. So, fourth option is the right answer. Benzene. Okay, C6H6. Which of the following is a non-benzenoid? Which of the following is non-benzenoid? So, you can see here there should be a benzene structure. First one is non-benzenoid because there is only triangle shape. Which of the following is a non-benzenoid? Okay, Acha, so here benzene is organic structure. So, here all of the above is the right answer. Okay. So, students, so with this we completed. So, this chapter, this exercise, this synopsis 2. So, synopsis 2, read it perfectly because in the classification of compounds is very important. So, I already told you that it consists of some millions of compounds. So many compounds you can come across in this organic chemistry. So, the classification is very important, and you know the classification, if you learn perfectly, it's become easy to, okay, naming the compound, okay, and also to classify the compounds which under the compound comes under which category, okay. So, that's what organic chemistry is very, very important. Little confusion, but you have to understand, okay. So, the name words itself that there will be understandable, like just now I told you, homocyclic. Homo means same, cyclic means what? Ring like structures. Heterocyclic, hetero, okay, aromatic which has characteristics and so on. So with this we stop our class, okay. Take care, bye.